Hello everyone, this is Vaibhav and you are watching the third lecture on the series Inverse Trigonometric Functions. Okay, so in case you have not watched the previous two lectures, then please go through the videos section of this channel and watch them and then comes to this section or the third lecture. Okay, so without wasting any time, let's get started. So firstly, we'll discuss the answers to the homework questions given to you in the previous session. Okay, the first question was given to you that y equals to cot of x equal to root of 3, then what is the value of x, giving you these four options. Okay, so let me tell you the answer. So two correct options we have. First is A and another is D, that means pi by 6 and 7 pi by 6 are the correct answers to this question. Okay, so basically x you need to find, and which is nothing but cot inverse root 3. Okay, simple logic, first value you can easily find using the trigonometric rule. At what angle the function cot would have the value root 3? You know that answer. It would be pi by 6 and not pi by 3. Okay, so you get the answer as A and not B, because you know in any particular quadrant if I'm talking about, then any trigonometric function would assume a particular value at a particular angle only, can't attain the same value at twice. That means at this and at this both angles it is having the value, suppose half I am talking about, so it can't be the possibility, right? Because it is one function, it can't have the two, and that is basically not the definition required for a function. Okay, so let's leave that thing. Now how to find the second one, I'll tell you the trick. I have earlier tell you the trick in the earlier classes, so I hope you know that. In case you don't, then look at this. Firstly, I draw the graph of how to find this value. Okay, so I denote these angles as 0, 90 degree, 180 degree and 270 degree. Okay, and drawing the line angle basically of pi by 6, which is this angle. Okay, now another angle would be this, which is nothing but 7 pi by 6. Now how to get this? As I told you, first you need to see cot angle is there and it is having the value positive, or you can look at it is having the value positive. Now cot is positive in which quadrant? In the first quadrant and in the third quadrant. So these are the two quadrants the cot function is positive. In the rest two functions we have the negativity of cot function, because we are using the rule all sine, tan and cos. Okay, basic rule, you know that. Now how to find this second angle? All angles are positive, so we need not to find the negative ones. That's clear. But in the if this okay, let me just brief you first this. So you just count this pi by 6, just multiply it by n. Now n is a positive integer, right? What is 2 pi by 6? It would be pi by 3. 3 pi by 6 would be this thing. 4 pi by 6 would come up over here. Then here comes the 5 pi by 6. 6 pi by 6 would be here. This is the angle 7 pi by 6. Here would be 8 pi by 6. This would be 9 pi by 6. The tan pi by 6, 11 pi by 6, and the 12 pi, which can be represented by 0 as well, no doubt. Okay. Now these two angles are clear, so the other two angles are 7 pi by 6 and 4 pi by 3. Now 4 pi by 3 can also be written like 8 pi by 6. Just multiply and divide by 2, so you'll get this. So this is basically 7 pi by 6 and this is 8 pi by 6. So which of the two options are correct? So you just calculate this angle, because either this would be the answer, either this or this. Anyone can be the answer. Now in order to check which one is your answer, because this is the basic simple trick that we used to do, and as per this requirement this is 30 degree, so this angle would also be 30 degrees, so this would be the answer 7 pi by 6. But firstly we'll verify this in order to get the correctness. Okay, so let me take this angle. Let me first take this angle, 8 pi by 6, in order to have a more clarification on the negative one. Okay, so 8 pi by 6 is nothing but 4 pi by 3. Okay, so cot of 4 pi by 3 would be, it is nothing but pi plus 60 degree. That means pi plus pi by 3, which is nothing but 4 pi by 3. So cot of pi plus any angle theta would be just only cot theta. So that means cot of pi plus pi by 3, which is nothing but cot 4 pi by 3, would be just cot pi by 3. That means cot 60. And what is cot 60? Cos 60 by sin 60. Right? Cot is nothing but cos by sin. So cot 60 would be cos 60 by sin 60. And what is this value? This is basically 1 upon square root 3 and not equal to this root 3 which you are finding. So that means this can't be the angle, thus the answer is this. And you can also verify the same. Basically, these are the quadrants, first, second, third, and fourth, that you are looking. And cot is positive in the first and third quadrants. This is just representing the same thing. Okay. So that means x equals to r cot. You know that cot inverse can also be written like arc cot. So this would be pi by 6, 7 pi by 6, and so on. So we want this 7 pi by 6 only. It can't be 8 pi by 6. So this option is wrong. Okay. Now, if this question comes in your exam, means in the board exam or in your school exams, so what you need to do then? First, you will write this thing. Okay, first you will explain this thing that cot is positive in first and the third quadrant. Okay, and negative in the rest quadrant. So we will look for the angles in these quadrants. Okay, then you will say from the trigonometric tables we know cot pi by 6 is root 3. Okay, also you may, because by the trick you will calculate this angle and will not tell you. You will not write this trick in the answer book. You will just write this, that now in the third quadrant cot of pi plus pi by 3. First write this pi plus pi by 6, then write which is cot 7 pi by 6, and it is also root 3. By the trick that cot pi plus pi by 6 is nothing but cot pi by 6, and which is nothing but just calculate that thing and write as root 3, and just write some negative values as well, one negative value, one positive value, and write, and so on. Many infinite number of values are possible, and then afterwards you will write this, that x would be this thing. So these are the angles possible for x, right? Okay, so I hope so you are clear with this question. Let's now move to the second one. Second one was showing, asking you to find the inverse of the given set A, and the options are given like this. Okay, now just remember something. Let me just draw a more important point to you. We do not find the inverse of any particular set. First thing. Second thing, we do not find the inverse of any relation. And the third and the most important thing, we find the inverse of an invertible function on. So these are the three important points that you need to remember in mind. If in this question, if in this question, A would not be a relation or would not be a function, then we could not find its inverse like this. And the answer would be none of these four options. Now because also now also its answer is none of the options are correct, but it's not because of this reason that it's not a function, because clearly A is a relation, it is a set with the ordered pairs and a function as well. So thus its inverse exists. Firstly, you need to say these things, that its inverse exists. Then only you can talk about its inverse. Until then, you can't talk. If I just give you a random set and find it and tell you find its inverse, you will just simply say its inverse is not possible if it's not a function. Firstly, you need to check whether it's a function, and for that you need to check whether it is a relation. So you need to check these basic things first, in order to find its inverse, whether its inverse exists. Okay, and also these are not the only conditions to be satisfied, but yes, these are the things that are important. It must be a function to have an inverse, and basically it must be a 1 1 onto function. If you have read the chapter relations and functions, okay, I just wrote over here that it's a function and its inverse exists, just for the easiness, because I hope so you have not known these facts if you have not studied the chapter relations and functions, because this is a necessary condition for the existence of the inverse of any function. It must be 1 1 and onto, and we'll look at it in a detail at a later stage in this chapter only, when we'll be defining the inverse trigonometric function. Okay, well, let's now not move that topic. Let's remain here. Okay, so I'm talking of inverse of this function only because of this condition, because this function that I'm defining like this, it is 1 1 and it is onto. You can look like this. That I have this. Okay, let me write over here. I have this 9, then I have this 4, I have this 6, and I have this 0 on one side. Another side I have this 0, then I have this 6 and 4. Now what is happening? 9 is mapped to 0, no problem. 4 is mapped to 6, no problem. 6 is also mapped to 4, and 0 is also mapped to 0. Now, what are the basic requirements for it to be a function? It must not have a, for two different ordered pairs, it must not have a same first component. And basically, it's not happening the case. It must not be there, like this. That means one has the two images. This thing can't be there for it to be a function. And it's not like here. We do not have this thing, right? Although we have this thing that 2 points have the same image. And I already told you that such type of function is called many one function. Right? It's the many one function over here. Okay. And basically already also I told you that many one function means if the function is 1 1, it can't be many one. If it's 1 1, it can't be many. So basically the explanation I wrote here is actually wrong if you know this. So this is a many one function. Many images, many elements are mapped to a single image. So it's not a 1 1 function. Clear? If it's not 1 1, we can't define its inverse. So that means its inverse does not exist. You just write does not exist. And also the same option would be correct, that none of the options would be correct, and this explanation would then become wrong. Okay, so let me just clear you this thing, that the options given to you means the question given to you says find the inverse. This explanation is wrong. Just cut this explanation and you write over here that inverse not exists. Its inverse does not exist. With the explanation you will write in the exam whenever this type of question will be asked. You will define the mapping, that it's like this mapping, that I can write the first components at one side and the second components on the other side, and just define the mapping. So basically it's like this. So it's not a 1 1, it is not 1 1. Whether it is onto or not, that's a different thing. We don't need that. And basically it's also onto, because every image has a pre-image, has some pre-image. That means no element is left out. Okay. Now, if I just change the question in a bit way, like if I just remove this line that 9 is mapped to 0, I just write 1 over here and map this 9 to 1, and this is not the thing. Okay. Then it would be a 1 1. Then it would be a 1 1 function. and then I can define the inverse like I did this. I just wrote this thing to let you be clear of how the inverse is being written. Okay, this is not the explanation of this question. Keep this thing in mind. So the if the question would be this 9 comma 1 pair, then it would be 1 1 on 2. So that means its inverse exists, and the inverse would be this. I said you just interchange the x and y components. So 9 comma 1 would become 1 comma 9. 4 comma 6 would become 6 comma 4. 6 comma 4 would become 4 comma 6. And 0 comma 0 would be 0 comma 0. So then this would be the inverse. So whenever the inverse type of questions come that find the inverse of this set, you need to verify it is a relation or not. If it is not a relation, just say its inverse doesn't. If it is a relation, then you need to verify whether it's a function or not. If it's a function, then you move proceed. And if it's a function, then you need to check whether that function is 1 1 or not. If it's not, then discard it. If it's 1 1, then verify the last property that whether it is onto or not. If it's onto, then you are done and then you can say that it's inverse. In case any of these properties fails to hold, you will say it is not 1. Okay, one more thing. In case you need not able to find, like in the question was, okay, the question was this 9 is mapped to 0. In case you don't able to find this 1 1 criteria by the graph, you may also use the definition that you know this thing. For the definition, if you have read this chapter, relations and functions, then you may be known this definition that whatever you write like this, that if f of a equals to f of b, then you need to show or find whether a equals to b or not. If it is, then it's a 1 1 function. But here you can directly say that f of a means the image of 9 is also 0 and image of 0 is also 0. That means 0 equals to 0. 0 is nothing but f of a and it is also f of b. But a and b are not equal in this case. Where what is a? A is your 9 and b is your 0. These are not equal, no? So by that definition, you can also say it's not a 1 1 function. And by the graph, you can directly say it's a many one function. Clear? So does its inverse not exist? So in this question, if there is 0, 9 comma 0 pair, then its inverse not exist. If I just replace 0 by any number 1, then its inverse will exist. Or if I just made 0 come to some other pair, then also its inverse will exist. So you need to verify these 4 things first, whether it's a relation or not, function or not, 1 1 or not, on 2 or not, in order to verify that. Now, in case you don't know how to verify these two properties, 1 1 and on 2, I'll make a separate video for that to help you understand how to check it's 1 1 or not. Okay, well, for now, you just understand this fact that each element has its unique image for the 1 1, and for the ontoness, you just need to verify that the range set do not have any element left out. That means it must not be like this. Suppose I have over 3 also, but there is no element in the domain that is mapped to this 3. There should not be like this condition for the onto. Like here, we do not have this type of condition that any point is left out, so that's why it's onto. So I hope this question is also clear and gave you some of the knowledge that you want. Okay, so let's now move to the next question, the third one. The third one question says you to find the value of a, where cosec of a is nothing but 2 by root 3, giving you the generalized values, and n is an integer. So I hope you have done this. We have done these type of questions many times in the class. So these are the answers to option number B and option number C are the correct one. Okay, so this type of question gives you another idea to write the values. Okay, First thing, as I always told you, you need to check the cosecant function is over here. So it's positive in which quadrant because its value is positive. If it's negative, then we need to check it's in which quadrant it is negative and find the values accordingly. Okay. So you know that cosec is positive in the first and the second quadrant only. That means our angles would be, that means the values of A would be lying only in the first quadrant or the second quadrant. Right. Now, the first value you can find out easily at which angle cosecant function would have the value 2 by root 3, which is nothing but pi by 3, because cosec pi by 3 is nothing but 1 upon sine pi by 3, and which is nothing but 2 by root 3. Now, as I told you, the trick you need to apply. So pi by 3 is nothing but 60 degrees. What is 2 pi by 3? Over here. 3 pi by 3 would be this. So that means your next answer would be just 2 pi by 3, as you're getting the similar one value only. So you'll write in the exams. Also cosec 2 pi by 3 is 1 upon this. And you will write over here that sine 2 pi by 3 is sine pi plus pi. Sine pi plus pi by 6. If I'm not wrong, cos 2 pi by 3 is nothing but that, na? Pi by 3 is, yes, cos pi plus pi by 3. Cos pi, pi minus pi by 3. Yes. Cos, yes, yes, yes. I'm talking of pi. Okay. So you'll write cos pi minus pi by 3 because this is the 30-degree angle. If I write according to this, I'll write cos pi by 2 plus pi by 3. Then I have to write that and find out its value and write dot dot dot, and also to write the negative values, that in the cosec at what negative values I'll get this positive. So this would be also be lying in this quadrant, and those would be like you have got 2 pi by 3. So just move now downwards for the negative value. 2 pi by 3, 0 pi by 3. So it would be minus 2 pi by 3, minus, okay, minus pi by 3, minus 2 pi by 3, 2 pi by, minus 3 pi by 3. It would be minus 4 pi by 3 and minus 5 pi by 3. So these would be the negative values. So in general, I can write it like this, two values. Pi by 3 plus 2n pi, because it will repeat after 2n pi. Similarly for 2 pi by 3, n is an integer. Now, I can replace this positive sign in both the things by the negative ones as well. There is no problem in that. Why? Can you answer? Because of this. Now, here what we will getting, we need to find these all values. We need to find that general form which contain all these values. Now, n is an integer. I put n is positive, then I'll get the positive values over here. Similarly, when I'll put n is also integer, if I put negative over here, then I'll get the positive value. If I put n positive, then I'll get the negative values, and if I put negative, then I'll get the positive. That means depending upon value of n, I'll get all the values. I need not to take care of this sign. It can either be positive or the negative, so thus these two options are correct. Pi by 3 minus 2n pi and pi by 2 pi by 3 plus 2n pi. It can't be this. It can't be n pi because it is repeating after 2n pi. That means it completes one full rotation, then repeats it. It would be n pi in the case when we have the values lying in the opposite quadrant, like this. When the value is lying in this quadrant, then it repeats after a value 90 degrees. So then we write n pi, or like this, in these types of situations. When the values, angles we need to find lie in this opposite quadrant, then we use this n pi. Otherwise, we use just 2n pi, right? Angles like here we did. So I hope so you are clear with this question as well. When do you find the value of arc of cot infinity? And it was asking you as a true and a false thing. Which one is correct? So basically, it's B is correct. It's false statement. Okay, so there are two things to show this. First thing, if I write r cot infinity, this is nothing but cot inverse infinity, right? Now, if for example I took 0. Now what is cot 0? Cot 0 is nothing but cos 0 over sin 0, and which is nothing but 1 over 0, which is nothing but not defined. Okay, so basically I write not defined sometimes as infinity. 1 by 0 is infinity. So 0 would be nothing but cot inverse of infinity. Okay, but basically it's not equal to infinity. We will say it's not defined because by notation, uh, you can see that the domain of the arc cotangent function, that means the inverse cot function, would have the domain is all real numbers, right? Excluding plus minus infinity. All real numbers x, but you can't take these infinity and minus infinity. So it's not defined basically directly from the domain. You can only define this cot function excluding these endpoints. It's not like less than equal to is there. Okay, it's not the thing. It's like just less than. That means you can't take this infinity. So whenever the question says you would not write this explanation that I just taught you, I'll just write this explanation in order to tell you that it's not defined and we'll write there, but it's not the correct way to write this. Of course you can write this that cot of 0 is not defined. But please don't write that 0 equal to cot of infinity, cot inverse infinity. Don't write that. It's not possible because it's not defined of the domain of the cotangent function or cotangent function that we use. Okay, so that's why this is false. It's not. It's equal to 1. No, it's not equal to 1. It's basically not defined. So it can't be equal to any real number. Let's now move to the final question, which was this. Question says that sec inverse of minus root 2 is 5 pi by 4 minus n pi, where n is in z. That means n is an integer and you need to tell whether it's true or false. So I hope you have done this question. Its answer is B. It's also false statement. Let me just tell you. First thing. First things comes first. Second function is negative. Now I am talking about negativity because it's written minus root 2. So second function is negative in the second and the third quadrant. Correct? Now, first thing to discard this to say whether it's true or false, you can directly see. If I just take n equals to 1, because n is an integer, it can take any integer value, so n would be 1. Then 5 pi by 4 minus n pi would be nothing but 5 pi over 4 minus pi, and which is nothing but pi by 4. So according to this statement, sec inverse of minus root 2 would be pi by 4, which lies in the first quadrant. But according to this thing that we just told you, so its value must lie in the second or the third quadrant. So that means D is correct. This is false statement. Directly you can say. Now, in exams, these types of questions do not come. You have a theoretical type of question. So you need to explain this thing. If they ask you to find this value, then you need to explain this thing. So you will write this thing. Okay. Now, then you will write first. You can easily find out the angle. First angle is just simple. That you will write sec of 3 pi by 4 is sec of pi by 2 plus pi by 4. I'll tell you the trick. Firstly, go through this, which is nothing but 1 upon cos of pi by 2 plus pi by 4. Now, what cos of 90 plus theta is nothing but minus sin theta. So, it will be minus root 2. Also, you'll write one positive value and one negative value, which I don't write. Also, write one negative value. So, then you will say that sec inverse of this thing would be, you know how to formulate this general notation. So, it would be 3 pi by 4 plus 2n pi and 5 pi by 4 plus 2n pi. No, no. Okay. Now the trick is also the same over here as we always do. It is asking root 2, negative root 2 basically, and it is a sec function. Now you know sec is just opposite of If I just say sec function, not sec inverse. Sec function is nothing but 1 upon cos. So sec will have the value root 2 when cos will have the value 1 by root 2, and which it has at the angle pi by 4. Okay. So pi by 4 in the first quadrant is this. Pi by 4 in the second quadrant would be, just increase the values as we do. This is pi by 4. This is 2 pi by 4. So it would be 3 pi by 4. 4 pi by 4 is this. It would be 5 pi by 4. Then it would be 6 pi by 4, 7 pi by 4, and 8 pi by 4. You want the angles in the second and third quadrant. These two values are correct. So that means 3 pi by 4 and the 5 pi by 4 component is correct. In order to find the negative value, just go downwards like this. So it is pi by 4, 0 pi by 4, minus pi by 4. But you want the angles in these two quadrants, not in this. You will discard negative 2 pi by 4. So negative 3 pi by 4 would be the angle, and negative 5 pi by 4 would be the angle. Similarly, go on continuously. You will get the desired angles whichever you want. Okay. And 2n pi because it 2n pi is because it rotates after every 2 pi period. Similarly for this and this. I told you, whenever we have the angle in the opposite direction, then we use the term n pi. Otherwise, we use 2n pi. No doubt. So I hope so this question is also clear to you. Now, in case you don't clear with any of these solutions or you don't agree, then please mention in the comment section your doubt. Now, let's start today's session. Okay, let me just tell you, today's session is a bit lengthy one because we'll be covering most of the important topics in this section like principal values and discussing out some examples as well. So let's start. Firstly, we'll define the inverse trigonometric function. Okay, now you must be thinking that we have already done this. In the first section itself, we defined how to write inverse function, but I'm not talking about that defining thing. Here, defining means we have told you that inverse function is not a function because it doesn't satisfy the basic requirement for a function. So, in order to make it a function, we'll define. Okay. Because of this fact that it's not a function, we proved at that time and see how it's not a function. So we now impose some restrictions, okay, on the functions to make them functions, okay, so that we can write this the inverse t and this word function with it. So in order to write this, I'll impose some restrictions in order to make it a function. Now, can you make a guess about which restrictions I'm talking about? That means where I have to put the restrictions to get my desired result to make it a function. Anyone? Well, basically, I'm talking about the restrictions on the domain and the range. As I told you about the domain and the range of inverse function, so we'll make the restrictions on the domain and the range to make it a function. So let us now define the inverse t function and what we will restrict. So firstly, what is the domain of arc sine function or the sine inverse function? You know that it is x from -1 to 1. That is a closed interval -1 comma 1. This is the domain of the sine inverse function. Okay, it is already restricted. That means it is already limited in a particular interval only. So we can't impose the restrictions on the domain. So what is left with us? The range. So we'll restrict the range then. Okay. So let us consider this sine function. Okay. Now the domain of sine inverse is nothing but the range of sine function, which is this. Now we take the domain of sine function is this: angles from minus pi by 2 to pi by 2, and sine of alpha would be x. Now clearly this function is 1, 1 and onto. That means invertible. Invertible means its inverse exists. Right? Invertible means its inverse exists. Inverse of this sine function. You know that in this region you can easily check it's 1, 1 and onto by taking the sum of the values. And also I'll tell you how to do that when we'll be dealing with the chapter relations and functions. But up till now, just you get this thing in mind that it's 1, 1 and onto. It's clear from the graph that I told you in the first lecture as well. So it's invertible. So I can write sine inverse function. The inverse would be, this thing would become the domain of sine inverse, and the domain would become the range. And the function would be sine inverse of x would be alpha from this. Clear? So the sine inverse function is not defined because it is because sine function is invertible in this region, so that's why its inverse exists. I told you it's a relation in function, no doubt. So to make it a function, we need to check the two facts. It's 1, 1 and onto. As I just told you now, they have just verified it very easy. So now, what we are gonna do? The restricted range. Okay. Now we will not say the range, we will say the restricted range. We have just restricted. So the sine inverse function would be minus pi by 2 to pi by 2. Basically closed interval. This is the close. That means the end points are also included. Pi by 2 and minus pi by 2 it can take the value. Okay. So in order to check whether it is 1, 1, I'll just plot the some basically mapping type and just take some of the values in the domain and the range for this function and just map it. For the sine and the for sine inverse as well. So firstly for the sine function, I have taken these domain points between this. I take minus pi by 2, minus pi by 6, pi by 4, pi by 3 and pi by 2. So the corresponding values according to the sine function would be these. You can easily calculate these with the help of trigonometric tables that you know. I'm just mapping this function. Minus pi by 2 would be up to minus 1, minus pi by 6 to minus half, pi by 4 to 1 by root 2, pi by 3 to root 3 by 2, and pi by 2 to 1. And this is basically the graph of mapping of sine function, how this is mapped. So with this a little mapping, you can also see that each one has a one image only, and there is no left out image in the range set. So that implies it's 1, 1 and onto. And this is just a diagrammatic representation, but actually this is not the proof that you need to do. This is just for your clarification of how the mapping is done. In the exam, if they ask you that show that it's 1, 1 or onto, you will not do this thing. Basically you can do this thing, but this is not the actual proof for doing verifying that it's a 1, 1 or not. It's just another some definition that we need to use, because I have now why let me tell you why this is not the actual proof. Because I have just chosen these 5 points only, but in this domain we have infinitely many number of points possible. So just showing the mapping for these 5 points is not necessary. We need to find the mapping for all the infinite number of points. So we have to use a general definition. And for that, I'll come up this thing a little later when we'll be studying the chapter relations and functions. Till now, you need not to worry. I'll tell you about that as well. Just you need to look how the mapping is being done. Similarly, now this sine function is thus 1, 1 and 2, so its inverse would exist. So now this range for sine function would become the domain of sine inverse, and the domain for sine function would be the range for sine inverse, and the mapping would be just the same. It would be just a reverse. Now minus 1 is mapped to minus 5 and so on. And this is just nothing but sine inverse graph. Okay, so this is also the thing to show you how the mapping is being done. just for clarification purpose. So now you know that inverse sine function is basically defined in this range. Domain is fixed -1, but the range is not this. So that's how I define the sine inverse function and call it a function because of this range only. Now, similarly, for the cosine function also, its inverse will exist if I just restrict its domain to the closed interval 0, pi for the cosine function. That means the domain for the cosine inverse function would be -1 to 1 and the range would be 0 to pi. So it's also restricted to this one. Now earlier I told you the domain and the range for the whole that you can take, but now I'm telling you the restricted range which is allowed for it to define a function. For this also I have just for the clarification purpose I have drawn the mapping for the sine cosine function and taking some of the points in its domain, the range, just did the mapping as we did in the previous section for the cosine function and for its inverse as well, like this. This is just for a clarification purpose that how it's 1 1 and on 2. So you need not to worry about it. I'll tell you this thing in the detail in the next video. Next means whenever we will be discussing about the relations and functions topic. Okay. Okay. One more thing. Also, you can tell me the topic that you want me to consider first after this inverse trigonometric functions chapter. You can put down your comments in the comments tab so that I can prepare for that from now on to let you consider about that. Okay. So this is just for the clarification purpose. This is not the actual proof to show that cosine function this is 1 1 and on, right? This is just for the clarification purpose. Main motive in this chapter is basically to this restricted range for the inverse cosine function. Main thing is that because that will help you to identify a number of questions. Now table is coming up. So this is basically the whole of the table that you need to remember basically. Okay. Now I can say that you can leave the table which I just shown you earlier about the domain and the range for the inverse function. Just you can totally leave that. You need not to remember the table. Just remember this table. This is important basically. This is basically important because many times the question would come like find the value of cosec inverse, suppose for any trigonometric function like cosec inverse of this particular function. So first you need to check whether it is defined or not. That means whether it lies in this domain or not. And if it is, then what can be the restricted range? From the you can easily know that it could be this only, nothing else. Right? These are the things that you need to remember. But now easy trick to remember this question. Sine and the cosine function is just closed interval -1 to 1. Right? Now as we have the sine and the cosine are the same. Tan and cot are the same. They are having all real numbers. Domain is just the same as in the previous table I showed you, excluding the endpoints minus infinity and infinity. And for the second cosec, it has this domain. These are both the same. X less than equals to -1 or greater than equal to 1. That means this can't be the thing. And you can include the end points, but not the middle points of -1 and 1. Either you just go less than -1, that's not an issue, or you go more than 1, including this 1 also. 1 and -1, that's not an issue. But you can't take the middle one point in the second cosec. Easy. Sine and cos would be -1 to 1. Second cos would be just the opposite. That means less than equal to -1, greater than equal to 1. and 10 God would be all real numbers excluding this minus infinity and infinity. You find it. Now comes the range. This is also very easy. Just you need to take these three things one by one, side by side. Sine inverse, tan inverse, and cosec inverse. Okay. All three functions use a sine. Sine, tan, and cosec. These would be having the similar kind of range. So sine would be having closed interval minus pi by 2 comma pi by 2. In tan also, range would be the same. Now just the difference, you can't include the end points. Why? Because it is infinity at those points. For the cosec, range would be the same. Just the thing, you can't use the value 0. The whole of the interval, closed interval is yours, excluding this 0 value. That means y cannot be 0. Otherwise it is 0. So sine, tan and cosec are having the same range lying in this closed interval minus pi by 2 comma pi by 2. Okay. Sine function, this whole closed interval we have. Tan function, whole open interval. And cosec function, whole closed interval excluding 0. Clear? Now for the cos function, now remaining three will have the same cos, cot and sec. The cos will have the closed interval 0 comma pi. So cot would be just open interval 0 comma pi. And sec would be closed interval 0 comma pi excluding pi by 2. Now just correlate the things. As in the sine, we have the whole closed interval, similarly in the cos. Then we consider for tan, we have the open interval. Similarly, when we consider the cot, it is just the open interval. Then if we consider this cosec, it was just excluding the middle point of this interval, basically with the 0. What is this interval? Let me just tell you. Okay, so this is, let me just clear. So just look at this. This is 0. This is basically pi by 2. And this is minus pi by 2 when we were negative. So this is basically the whole of the range, the sine function, including this line. For the tan function, you can't use this line. You can use all the angles lying in between, minus pi by 2 and pi by 2. For the tan function, you can use whole of the closed interval excluding the 0. You can't use the 0. Now, for the cot function, that means for the cos. Okay, so this would be now pi. For the cos function, this closed interval, that means 0 to pi, this whole of the values you can use, including lying on this line. For the cot function, just open it. That means now only the open interval, 0 comma pi. Can't use these end points, just the open interval, all the angles lying in between 0 and pi. And for the sec function, all of these points in the closed interval, excluding this middle, pi by 2. So these are both correlating to each other. Both are like in a same manner, I can say. The sine and for the cos. So it's basically the same thing, and it's the easy one to remember. And you need to remember this at any cost. I tell you the trick how to remember. Just take these three side by side and then take these three. Cos, cot and sec. In that case, you can remember this table, which is very, very, very important. Let's now move forward and have some questions. Okay. So one question that I have in my mind, are the value of the ranges fixed in defining the inverse key functions? Means the values that I have just used, is range value. Are these fixed? That means there's I can use just this minus pi by 2, pi by 2, 0, comma pi, this, only these, or any other possible. Because we have infinite number of range, na? Range is just infinite. So can I use just this small? So answer to your question is no. This is not the only value. There can be other range possible to define the inverse trigonometric functions. For example, for the cos inverse function, we have used the range as closed interval 0, comma 5. We could also have used this closed interval minus pi, comma 0, or closed interval minus 2, comma pi, minus 2 pi, comma minus 5. We can use them, no doubt. And they, not only these, many more. Just you need to define the function in that particular domain, define the function in that domain and range, and just uh, prove that it is 1 and on 2. You need to just show this to say that its inverse exists in this. But so why are we using these values that I just told you? Why to remember them if there are infinitely many values possible? Basically, we use them because these are the values that are always used in all of the books and the prescribed values that we use. Why? Because these values make the graph for small values of the y, and which makes the graph easy to understand and to draw, right? And these are the values that are generally being followed by every book and every writer basically, okay, and every teacher basically. So these are the, you can say, the general values that everyone is using to define the function. Although you can use other values as well, because there is no universal agreement on the remaining portions of the range. You can use them, but these are the values that are generally being used. Okay, so whenever you would be asking the questions in the exam, it would be considering only these restricted ranges only. So that's why you need to remember those tables, and it's easy. It's not a difficult task to remember that table. Okay, I have told you the trick. Just follow that, and you're done. So I hope so. Up till now, I'm clear. So let's now have some quick questionnaire to clear the things that you have just learned. 3 short questions: finding the value of sec inverse half. Then in the second, the equality of the two sides, whether these are equal or not. And for the third one, finding the value of x, that where our x lies in this or in this. Okay, so pause the video right now. Play it after a few times when you are done with these 3 questions, and I'll discuss its answers with its explanation. Okay, so I hope so you are done with these 3 questions. Let me now discuss the answers, which are this. So for the first question, none of the given option is correct. For the second one, second option is correct. And the third one, first option is correct. Okay, in case you have got not all the answers are correct, please watch this explanation. For the first one, sec inverse of half, whether it is pi by 2 or pi by 4, it's none. Why? Same trick. Second function is positive in the first and the fourth quadrants. Pi by 2 and pi by 4 lies in the first quadrant only. Okay, now, what is it? Now I just told you the definition that at which values we can define these inverse functions. So we will use that concept to determine the angle. Because why? Because you don't know. Because you don't know at which angle the sec will have the value half. You know only the first grade angles, so you don't know when it would be having this value. So you will go by the domain concept. Now the domain of inverse secant function is what? It's this. I can denote it like this. X less than equal to minus 1, greater than equal to 1. That means the value can be either less than equal to minus 1 or greater equals to 1. That means this open interval minus infinity closed minus 1 union closed one and open. That means this x, this is the x, so it must lie in this domain. Now it is half. Half is not lying in this interval, in the domain basically, because half is neither less than minus 1, neither greater than 1. It's lying in this middle one, which is not there. So that means this is not defined actually, and we can't take any value. So it's just again the same thing, it's not defined. Now the trick, you need to just look at this. Whenever now the questions will become finding this inverse value, you need to first verify with its domain whether it is defined or not. If it is defined, then only you can find its value. If it's not, then just say simply not defined. Because maybe this kind of thing can happen that you're just finding the value and you before checking whether it's defined or not. Like this question. If you just follow the thing that at what angle it is half or what angle it is up, it can't take the value. But you don't know because you know only the value only at the prescribed angle. Okay. So that's why just check this domain first in order to ensure whether that inverse trigonometric function at that value is defined or not in order to get the clear idea. Okay, the important tip is there. Please keep this thing in mind. Now, for the second question, it was asking you whether these two sets are equal or not, and it is basically false. These are not equal. So let me just first find the elements of both the sets to get a clear idea. Now, look at this definition, how the first set is defined. It is saying cot of x equal to 3 implies x would be cot inverse 3. Now, before finding the value of x, as I just told you, firstly let me check whether this is defined or not. You know, domain of cot function is nothing but whole real numbers excluding minus infinity, infinity you can't take that. And 3 is not, 3 is just a real number. So that means cot inverse 3 is defined. That's not an issue over here. Now, look at this another definition for the second set that is given to you. Minus half equals to cosec x implies what? X would be cosec inverse minus half. Let's now first verify whether it's defined or not. Domain of cosec inverse function is this. Same as for the sec function. Less than equal to minus 1, greater than equal to 1. But again, minus half does not lie in this interval. So that means this is not defined. Cosec inverse function is not half is not defined. You can't write like that. So that means we have elements in the first set. We can have elements in the first set, but second set, this definition is not defined. That means this is just the empty set. There is no point in the set. This is empty while the other set is not empty. So these can't be equal. Because we don't know, right now we don't know the elements in the set, but we know there can be elements in the set that satisfy this condition. And that would be, elements would be like this. X equal to cot inverse 3 comma pi comma y. So these would be the pairs that with the angles of the first set. While for the second one, cosec inverse minus half is not defined. So its element would be just half. Now half, sorry, 5, not half, 5. Now, 5 is not equal to this because this is not empty. So thus these sets both are not equal. So this statement is okay. Let's now move to the final question. If y is equal to cos of x equals to half, then what will be the value of x? It's not asking you to find the value of x. it is now asking you that where the value of x lies, in this or in this. Okay, so it is just an easy question. You need to keep that thing in mind, and its answer is this. That is in the first quadrant given not in the first quadrant, in the first interval given to you, the value of x. How to show this? Okay, simple trick. Cosine function is positive in the first and the fourth quadrant. Okay, now this is the thing you need to do first. Now y is equal to cos of x equal 1 implies x would be cos inverse 1. Okay, so I just proceeded over here. You need not to do that first. You need to first verify whether this is defined or not. Now what is cos inverse 1? It is asking, na? So what is the domain of cos function? It's this minus 1 comma 1, if you remember, right? It's closed interval minus 1 comma 1 is the domain of the cos function, cos inverse function, and basically 1 lies in this interval. So that means cos inverse 1 is defined. Now we can proceed further. So you need to first show this. Now same thing, cos of 0 is 1 implies cos inverse 1 would be 0, and which lies in the domain of the inverse of cosine function. This you also like that this 0 lies in this. Okay, sorry. Basically, it's not the domain, it's the range, because it's the value that you are getting. So it's the range. So cos inverse 1 is 0, which lies in the range of the inverse cosine function. Not this. This is not the range. Range is the closed interval 0 comma pi. If you just remember that. So this is some printing mistake. Sorry. Okay. So basically, cos inverse 1 is 0, and which lies in the range of the inverse cosine function, which is this, because this 0 is included. No? This is closed interval. Okay. So you know that now the value is 0, and you know it lies in this. But this is not the option given to you, and need not to correct this second one because of this 0 comma pi and 0 comma pi. Just look at this. Here the interval is closed. That means 0 is included, but here it is open. That means 0 is not there in this interval, right? But we are getting the value 0, so 0 is not here, but here we have the 0. Why? If we just look, this is pi by 4, this is minus pi by 4, and this is nothing but 0. So it's the closed interval. That means the angles are included here. This is the open one, and all the angles between are included, and 0 is also there. So that's A is the correct option. Clear? You need to first check whether it is defined or not. Then you need to find its value, and the question can be like this: in which region it lies. You just remember the concept of domain and range. That would be very helpful in the questions from now. Okay, so now we are done with these questions. Let me now have you the concept of the principal value, which is again an important point. What are the principal values of the inverse trigonometric functions? These are the important ones because sometimes the question comes directly that find the principal value of this inverse trigonometric function. How to do that? Now we know that the restricted range for the sine function is nothing but minus pi by closed interval minus pi by 2 comma pi by 2. We know this. Now also we know that there are other range possible for the arc cosine function. So likewise for sine function as well. These and this. So these are the both restricted ranges possible for sine inverse function as well, and so on. That means many more possible, in which the sine function is 1 1 and on 2. That means it's invertible. That means sine inverse exists. Not only for this range, and for many other ranges as well. So what we're gonna do now? We define the principal value. How? So we consider only the least numerical value among all the values of angle whose sine is x, and call it the principal value of sine inverse. Okay. So basically the principal value of any trigonometric function, for example, I'm considering for sine inverse, so it would be the least numerical value among all the values of the angle whose sine is x. That means suppose I have to find the value of sine inverse of, suppose I have to find this 1. I have to find the value of sine inverse 1. Now we know that sine inverse 1 is nothing but at pi by 2. Okay. And also at many other angles. So we'll consider, if we have to find this value, principal value, what you will find? You will find the least numerical value among all these values possible, the smallest value possible, and call it the principal value. That's it. Here in this case, it would be pi by 2. So that would be the principal value of sine inverse 1. Clear? So thus I can define the principal value function for inverse sine function for real numbers is the set x comma y is equal to sine inverse x, domain is fixed -1 to 1, and the range is now minus pi by 2 comma pi, which is nothing but the smallest range possible, and that is basically the principal value. Okay, so whenever you have been asked to find the principal value, you will just consider this domain only, not any of these, because this is the smallest value lie in this domain only, and just consider angle from this domain only whenever the word principal value would come. Clear? Okay, now let's move forward. So now I can say, so the smallest numerical value, either positive or negative, so it can also be positive and negative, as we see in the sine function, it's lying between closed interval minus pi by 2 to pi by 2, so it can either be positive or negative, both values are lying in that. Of an inverse trigonometric function is the principal value for the function. Now an important trick or the short note which you can use in your question. Whenever you have been asked to find the value principal values of sine inverse, tan inverse, or cosec inverse, so basically those angles would lie between minus pi by 2 and pi by 2. I am not including the end points pi by 2 and minus pi by 2. I am saying between. And similarly, the principal values of cos inverse, cot inverse, and sec inverse would be the angles lying between 0 and pi. Now this result is just similar to the one told you earlier when you will be remembering this domain and the restricted range concept table. So there also I told you that sine, tan, and cosec would have the same range minus pi to pi by 2, and cot, cos, and sec would have the same range 0 to pi. Similarly over here, principal values will be lying in this. I am not including or excluding any of these endpoints. We will discuss it more later. So suppose I have to find the principal value of sine inverse 1 by root. It is being asked me. Basically it's 45 degree. You know that clearly sine have the value 1 by root 2 at 45 by 4. So you know that. Now if I have to find this value, principal value, how will I proceed? You know that firstly you will write that the principal value for sine inverse function lies between minus pi by 2 and pi by 2. Now, sine pi by 4, sine 3 pi by 4, sine 9 pi by 4 up to sine minus 5 pi by 4 minus 7 pi by 4 and dot would have the same value 1 by root. You know now how to calculate these bigger angles. So just write like this. Now, then write this. That sine inverse 1 by root 2 would be pi by 4, 3 pi by 4, 9 pi by 4, minus 5 pi by 4, minus 7 pi by 4, and so on. Up till now you have found all the. Okay, now you write that the principal value for the arc sine function of 1 by root 2 would be pi by 4, or the 45 will be the numerical value, smallest numerical value lying in the restricted range. I'm talking would lie between this. So it would be pi by 4, that is 45. Clear? Or directly you can use this, that it is signed, so that means answer would lie between this one and this one. So directly you can say, but you need to show this reasoning in the exam whenever the question comes. Clear? So I hope so up till this thing the things are being clear to you. Have some example. Suppose I have to find the principal value of arc sine of minus root 3 by 2. Okay. So before finding, what you need to do, you need to check whether it is defined or not. Which you know it is how? What is minus root 3 by 2? Minus root 3 by 2 is basically lying in the closed interval minus 1 comma 1. Okay. It's not basically greater, it's not basically less than minus 1. Okay. It's basically greater than, because root 3 is nothing but 1.7. Okay. Root 3 has the value 1.7 something about, and it is dividing by 2. So it would be lying in this minus 1 and 1 only. In the closed interval minus 1 comma 1. So that means this we can say this is defined. Now minus root 3 by 2 is sine of pi plus pi by 3. I told you how to find the value. Sine is negative in the third and the fourth quadrants. So it would be pi plus pi by 3, and also 3 pi by 2 plus pi by 6, and also minus pi by 3 minus 2 pi by 3, and so on. So principal value would be the least one, which would be pi by 3 in this case, minus pi by 3. Minus is over here. So it would be minus pi by 3 over in this case, because this is the only value that lies in the region that we are considering. So we are considering that minus 90 degree and 90 degree, right? We want the angle in that quadrant only, because that is the restricted range. And among these all values, we have just minus pi by 3 in that, or minus 60 degree per se. So that is the principal value of sine inverse of minus root 3 by 2. So in this way, you will do these types of questions and elaborate your answer as much as possible in order to have a clear understanding by the checker who is going to check your copy. Okay, so whenever you are doing this question, just elaborate it as much as possible. Okay, as I told you. Now, an important note that will affect all your results you have learned up to now. Unless otherwise stated, by any inverse value of a t function is meant its principal value. Important. That means what? Whenever you have to find the value of inverse trigonometric function. Suppose you are given that find the value of suppose sec function is defined in the range greater than equal to 1. Okay, suppose you have to find this sec inverse of 3. Okay, then what you need to do? You need not to find all the values and write it in the form like pi by 3 plus 2 and pi in the general way as you did. What you will do? You will have to find the principal value. If they say find this value, that means they are asking you to find the principal value of that value. Okay. So many times the question would not say this word principal value to you. Okay. So they would just say its value is what. So you need to remember that have to find the principal value. So from now onwards, you know this thing. So whenever any question would come, find inverse of this function or like cos inverse of this particular value, then you have to find the principal value. This is the important point you need to keep in mind. They would not tell you find the principal value. They would indirectly say you find this means the principal. Clear? Now a table is coming. Important table. Need to remember the contents of this table as well. And I will tell you it would be easy if you just make this table on a paper A4 size sheet and just paste this on the wall that you would like to study before, and just every time whenever you're gonna study, just look at this table once and you're gonna remember these values easily. It's not very difficult to learn or to just look at the values. Let me just tell you the trick. So this column is clear. It is just the functions. This domain is clear. It is the third time I'm remembering you the domains. We have seen in the third table this domain. Principal value also clear to you. These are nothing but these are the values you need to remember. More or like the same for the range. Like for the sine it's the same. For cos it's the same. For tan also the same. For cot also. For sec also and for cosec also. Just an important difference in the sec. This thing. Earlier when we defined the range, restricted range for the sec function, we used to include 0, but in the principal value we do not include 0. Okay. So from now onwards you will also not include the 0 and the principal value. Now what these two columns represent. So these are the basically giving you an extra help. In the sense, if you need to find, suppose you need to find sec inverse of minus 5. It is defined basically because its domain is this thing and it is less than minus 1. Now, you know its value would be lying in this. Open 0, closed pi, and it would not be pi by 2. But if you want to know more clear result, you can use these ranges. So minus 5 is basically x and it is less than 0. So your answer would lying up be in this region. Open pi by 2, closed pi. That means from this range, your answer shifts to this range. So directly your interval cuts into half. From 0 to pi, so it was an interval from 0 to pi. Now it is just from pi by 2 to pi. So it's just reduced your work a little more. And it's not difficult to remember this table. Basically, easy thing is that for x greater than equal to 0 and for x less than equal to 0, these are the two things that you are drawing for. Just look at this thing. You need to remember the principal value. Just remember that and this value. Nothing else. You need to include 0 to pi by 2 in every of the interval for x greater than equal to 0. Now, okay, so everywhere you need to write y, 0 and pi by 2. Now the condition whether to include the end points or not, that will depend on the principal value. For example, in this principal value 0 and pi by 2 are included, so less than equal to sign comes. In this also 0 and pi by 2 are included, so equality comes. But in this, like 0 is included but pi by 2 is not. So less than equal to is here, but strictly less than is over here. Similarly, 0 is not included but pi by 2 is included in the middle. So less than and less than equal to. Similarly for here, 0 is not included, pi by 2 is not included. So just strictly less than sign is come. For this, 0 is not included and pi by 2 is included. Less than and less than equal to. Very easy trick to remember that for x greater than equal to 0, just you need to put 0 and pi by 2 always. And the equality or the not equality of these end points will come from this principal value. And for this x less than equal to 0, very easy. Just need to find write the remaining range after this. Because this range we are separating into two parts, this and this, for each other case also. So if you know this range, you can write the remaining range. Like for minus pi by 2 to pi by 2 close, you write 0 to pi by 2. What is left? Minus pi by 2 to 0. Just write that. Similarly for this. Now I would say you just learn these things as well by the trick that I just told you. That write this, learn this and this value. You can also write another rest of the values with the help of the interval, whether to include and points or not, and write this with the left out range. That means from any of the range you have written this, so just exclude the points of here and write the rest. Like, so here we have this 0 comma pi. That means all the angles lying between 0 and pi, but you are not including 0 and pi. So you have written this all the angles from 0 to pi by 2. So what are left? From pi by 2 to pi are left. Now you have included pi by 2 over here, so you can't include pi by 2 over here, so it's strictly less than because strictly less than pi is there. So in this way you can find out. Now I must say you must learn these values by the trick I have told you. In case you don't, that's not make an issue, but you must remember these principal values. In case you don't remember these two columns, no problem. This will just make your work easy, but if you don't want, just don't. But just remember or learn these principal values. These are just the important. These are the important. You can't just exclude these principal values. These are the important. Okay. So now we are ready to move to the examples. So example number 1. These examples are from the book I told you, Western Publications written by O.P. Malhotra. So I'm following that book only. In case you want me to follow any other book, please mention the comment section. So the example says find with reasons it is asking you which of the following functions are not defined. Okay. This is the first hint that I am giving you. Just recall the domain and the range. Range means the restricted range for the inverse t functions I am telling you. First question is cosec inverse half. As I am discussing these examples, you can do one thing. Pause the video after the question and then resumes after you are done. Okay. So basically, you know that whether first you need to verify that cosec inverse is defined in this range or not. So for that, what you need to do? You need to just verify whether it is having the domain or not. Now, you know that the domain for the cosec function is this. Greater than equal to 1, less than equal to minus 1. But half is not lying in this domain. So that means it is not defined. This is the reason you will tell. With reason, no? This is the reason. Easy. Let's move to another. Tan inverse 1. You need not to find the value. You just need to tell whether it is defined or not. Simple. I hope you are done. Again, tan inverse domain is just all real numbers excluding minus infinity and plus infinity, which is not this. That means it's a real number. So it is defined clearly. and you know its value is pi by 4. Next question, or the example basically, cos inverse minus 3 by 2. What is this? It's defined or not? Find it out. So I hope so you are done with this example. Let me tell you. It is not defined because you know that the domain for cos inverse is just minus 1 to 1, closed interval, and minus 3 by 2 means minus 1.5, which is greater than 1. So it does not lie in this in domain. No? If it does not lie, then it's not defined. Simple. So I hope up till now you are clear with these examples. So let's move forward with another example. Okay. What is sine inverse of 1.7 over 1.8? I hope so you are done. No. 1.7 over 1.8 is what? 17 by 80. And basically numerator is less than denominator. That means this value is less than 1. And less than 1 means what? It lies in the domain for the sine inverse function, which is closed interval minus 1 comma 1. That means this is defined. Right? Next one example. Cot inverse 7. Very easy. This we have done. It is basically defined because the domain for the cotangent function is nothing but all the real numbers. And 7 is a real number. So that's why it is defined. Very easy. You can just see how quickly we can just do these questions with the help of the domain. If you know the domain, you can just easily do this question. Next, sec inverse 4 by 5. Again, domain for sec inverse function is the same for the cosec as well. Less than equal to minus 1, greater than equal to 1. And 4 by 5 is now less than 1. And which is the wrong thing. Because it does not lie, it is neither greater than equal to 1 nor less than equal to minus 1. So that's why it is not defined. Okay? It is not. So now we are done with this examples as well. So I hope it's more than the time required for me. I hope I'm clear with all the things I have told you. This is the most important session for today for this chapter, discussing the restricted range and also the principal values, which are the most important ones. So let me conclude the section and give you some of the homework questions. Okay, these are the homework questions. First one is saying you using principal. Okay, let me tell you, if it was not given to you that using principal values, then also you will use the principal values. Because from now onwards, whenever the inverse function you need to calculate, just you need to consider the principal values. Okay, so it is saying you using principal values, find this value among the options, which is correct. Similarly, for second function, you need to find its value. For the third one, you need to find the value of y lies in which of the following interval. Okay. For the fourth one, you need to check whether it is true or false. And similarly, for the fifth one, just remember the principal values you need to use on. And basically, the range, try to remember those tables that I taught you. And then do these questions. Very easy questions are these. Okay. So I hope, let me just conclude this session now. And you like this video. If you like this video and if you feel that you need to do something for me as well, then you can do that by just liking this video, sharing this video with your friends and to the people you know, so that they can be benefited with this video as well. And just subscribe my channel for the further notification and the updates about the new video session. And we'll meet soon on the next lecture. And basically, as I told you in the second video only in the comments that I think of that after every three video, we would be having a quiz. Quiz basically is a test on the topics we have covered in that three video session. Okay, and that quiz video uploaded in the morning, and the answers, that means the solutions for that, will be provided to you, video solutions, by the evening of that day only. Okay, so by this up till now we are having done with the three videos. So we would be having a quiz now, and I'll update you about the quiz. I'll upload the quiz after, not tomorrow, but day after tomorrow. We'll have a quiz. Okay, and the video solutions will be provided to you by the evening, so you can check your answers. I'll update the time in the quiz, the number of questions you need to do, and the time taken required to take the questions. Just be with that time, write your answers clearly, and at the evening, match your answers and write down your scores in the comment section so that I can know how much you have learned and how much you get. And in case of further clarification of any topic or any question, please mention your doubt in the comment section so that I can clarify your doubt in the next video when we'll be having that. So up till then, see you soon. Thank you.